you know the book of Ted Nelson, Computer Lib Dream Machines, which was very popular in the last century, looked at computers and the way they should be, not the way it actually turned out today. And so we will have a talk after we learned about the Canon Cat, now about the Spectrum Next computer. And so Matteo Vitturi will tell us about that.
Yes,
and
yes.
I'm also very curious because I have a Spectrum Next on my own.
Okay. I invite you to get to show to magnify my screen, because I have no interface. I just put in place a webcam to see my
I will do it
screen.
like this.
I'm sorry, but I will buy in the future. I hope you can see everything. It's quite large, but okay. This is I was playing around and already loaded RP0 interface. What I did, well, you know that the next Spectrum Next is a FPGA based computer, and inside it it has a Raspberry Pi 0. So it can be accessed via UART, Universal Asynchronous Receiver Transmitter. I hope I spelled good. And well, to achieve my purpose to talk with this Raspberry Pi 0, I had to read the documentation and find out how to select the correct UART and the baud rate. So I put in place a loop, a simple loop that pulls the keyboard and transmit the key and receive anything the Raspberry send back and display it to screen. It's just like that. There were some constraint because there is no transmit buffer. There is only 2012 bytes long receiver buffer, and we have a notoriously slow machine, 28 megahertz, and we can go to one. It's not very fast anyway. So let me start. Okay. Okay, this is the supervisor. I restarted it, and the terminal is just like that. So I transformed my ZX Spectrum into a dumb terminal that talks with the Raspberry, and we can see what it got. I'm sorry, I'm very. The keyboard is not very friendly. Okay, this is just a simple Unix-like, Linux-like system. To go back to Forth, I have to press break in this way, so we return to our system. I was looking to, sorry, 900 list. Okay. This is where I began to code. What we can do? Well, I put in place a few Forth words that ask something and display its the reply, then ask again something. Let me run simply. I mean, I put in place a wrapper around the Raspberry Pi 0 this way. So, and coded as some simple words definitions that can talk and receive back anything. So let me see. Let me you see. I'm sorry. I did the wrong 899. Sorry. Sorry again. I forgot to import this definition. 899, load. Okay, this is as far as can go. I mean, from Forth, I asked the bash version and the Raspberry replied that number. I asked again, what date is now and what time is now? Well, okay, that's all. You can see that the date is wrong. I mean, the Raspberry, when it boots at the 2021. So I think I just can modify and put what time is now. Yeah, is almost correct. What I foresee it was when I could run this stream. A99 load. Okay, when we go back to term and see what it does, this is the Unix terminal date, and I correctly set up the correct date, the today date and time in Raspberry Pi. What can we do? We can do something like Python. And this is Python. It's fantastic. We can do some very long multiplication and see what it does. Spectrum cannot do this in such a short time. So this is a real good experiment from my point of view. Any questions? This is as far as I went in my journey to the Spectrum.
So Matteo, if you're writing a program for the Spectrum next in Z80 using Forth, you could use this system to get the Raspberry Pi Zero with the fast ARM processor to do, acceleration of your Forth program.
Yes.
So you've effectively got a set of words that can communicate with the Raspberry Pi from Forth over the UART.
Yes.
And if you wanted to do a complicated calculation, maybe some 3D mathematics or something called matrix multiplications, you'd actually get the. Yeah, go ahead.
You're right. I put in place these few words to put in place a communication. It should be fast. It is not so fast because there is much delay from the ask and the reply. So if we want to do something really usable, we should put in place some peculiar protocol that continuously sends bytes and receives packets from the Raspberry. So this is not the case. This is just a terminal. I transform my Spectrum in a dumb terminal, just the keyboard, and see what it does. So, but your idea is good. Is fine. The only problem is to code and test it. But
sure. Yeah, I mean, as you pointed out, I mean, the Z80 is not very fast to do, for instance, floating point maths, right? It's whereas the Raspberry Pi, just because it's an ARM running at 700 megahertz, it's very fast.
It's very fast. So
you can offload computation to that Raspberry Pi in the Spectrum next and do things that nobody in the 80s thought would be thought possible.
I have in mind some ideas to improve this protocol. This is just a probe to see what the Raspberry can do. But you're right. The Spectrum is I mean, a stop door is faster than the Spectrum. I mean, okay. Or a doorstop. What do you say in English? Doorstop.
Yeah.
A doorstop is faster than the Spectrum, but the Raspberry is faster. So we can do very long calculation. I mean, we could prepare in advance any script in Python, for example, and trigger any of them by 1 byte sent from the Spectrum and receive back the reply, the long computational 3D graphics and so on. Yes. Your point is what I should do.
All right. So yeah, thank you very much for showing this. Are there any additional questions? Okay, doesn't seem to be the case. So thank you very much indeed. And we have a situation that we don't normally have. We're ahead of time.